I'll start this off by saying that this may take multiple parts to completely make my point. My point is, what is science? Most people use the term science without actually knowing what it is in reality. Science deals not with facts. Like, you'll hear people say, well, science deals with only facts. Well, that's true. Science is the end goal of any scientific pursuit is to find a fact of some kind. But before you reach facts, you have predictions, fiction, things that you want to test. And science deals with testing more than anything else. And it's a very logical way that science works. You see, science works with the idea that you'll have a prediction, and eventually your end goal is you want to reach a theory. So I'll show you an example of this. I have the prediction that if I pick this thing of gum, pick it up and let it go, it is going to fall. That is my prediction. So I'll want to utilize something called a scientific method. The scientific method is a procedure that people use to arrive to a conclusion of some kind. Now, there is a formal scientific method and an informal scientific method. Most people, either way, are using the same thing. The formal method just involves lots of writing and stuff, but I will employ the informal scientific method. I will start with a question. What happens if I pick this up and let it go? Okay? Then I'm going to form a prediction. Prediction, then it's called a hypothesis. Hypothesis is, your prediction. I'll say, if I pick it up and let it go, then it will fall because of something called gravity. Okay, that is a hypothesis. Then I'll form a scientific strategy. I'll outline some kind of resources I'll need. In this case, I merely need an object to pick up and drop. And I'll develop a method, which is, again, I will pick it up and let it go. Then I'll observe what happens. So I'm going to pick it up, let it go, and lo and behold, it fell. Okay. Then that observation I just made is an observation. I observed and, oh my god, it fell. It's fascinating. Of course, I'm not done, because I have to be thorough. I'll pick it up, and I'll let it go, because right now I just have one point of data. Okay, and that data is one object picked up, dropped, and fell. I pick up another one, pick it up, let it go, it fell. Okay, and I could keep repeating this to my heart's content until I finally came to the conclusion that, turns out that when you pick an object up and let it go, it falls. Okay, that is my conclusion. Now, tested enough times under different situations, I could eventually form such a solid conclusion that I could make an argument. This argument would be called a theory. Most people are concerned, or not concerned, but confused about what a theory actually is. You'll hear people say, well, it's just a theory. That doesn't make it true. Yes, it does. A theory is, for all intents and purposes, as true as much of a fact as you're ever going to find anywhere in life. Okay. Some examples of things that people call theories that aren't actually theories is like the theory of how life got started from self-replicating molecules. It's not a theory; it's a hypothesis. See, and this theory involves the idea that proteins synthesized naturally on Earth by forming long carbon chains or hydrocarbon chains, and these eventually started producing self-replicating structures that eventually became life. That is a good hypothesis. It's very logical. It has been tested, but it has not been confirmed as true or false. There are other opposing hypotheses. Another theory, or another thing people call theories, may or may not be true, is how the dinosaurs went extinct. See, we don't know. The most common consensus is it was either an asteroid or some volcanic event. that would have disrupted the ecosystem severely enough that large life forms like dinosaurs could no longer exist. And this then paved the way for mammals and birds. Well, birds themselves being small dinosaurs, paved the way for those ones to take over. But this cannot be confirmed or denied yet. But we do have a good amount of evidence supporting it. Conversely, there's a lot of things that people call just a theory, such as evolution. Evolution has been tested and observed so many times that it's really hard to deny it's not a theory. And being a theory, we can then do stuff with it and test it. And lo and behold, in our tests, we have found that, yes, evolution does work. It's slow, not very dramatic. It doesn't lead to the optimum. But you see, a poor understanding of what evolution actually is doesn't make it false. Evolution is hard to deny. Even something as simple as people have grown taller over the last century is an example of evolution. See, it's the idea that tall people passed on tall genes, and oh my god, their kids are also tall. That's a theory. It's been tested and it's been confirmed. See? So evolution is every bit as much of a theory as gravity. No one denies gravity. No one denies that the Earth is... I'll scratch that. There are some people who don't believe the Earth is round. But, we can look at the Earth and we can say, Earth is round, because we have satellites in space that are currently looking at the Earth right now as we speak and making that observation. Okay. Now, here's the one problem with theories, is that there does always exist the possibility that a theory is wrong. See, with a theory, you do run the risk of being wrong. But that's true with anything. What you do have is a very close, almost non-zero probability that they are not wrong. But, see, that's a theory. And that's science. Science is the idea that you can take something, have an idea, and test it. Okay? My next video, which will be coming soon, will deal with what isn't science. And so this one just outlined what is science and what is a theory. So, I'll hope to see you soon.